Bismillahirrahmanirrahim. This is video about graph of rational function. A rational function is a function such as fx equal to px over qx, where px is polynomial function, also qx is the polynomial function. Here is a strategy for graphing a rational function. Step 1. Find x and y intercepts. Step 2. Find a vertical and horizontal asymptote. Step 3. Determine the critical points, interval of increasing and decreasing, extremum point, interval where the graph is concave up or concave down, and inflection point. Then we can plot and sketch the graph by using their information. Here is the question. Given fx equal to 7x minus 1 divided by 5 minus x, find, if any, the x-intercept and y-intercept, vertical and horizontal asymptote, f prime x and f double prime x, extremum and inflection point. Using the above information, sketch the graph. So first, we will find x-intercept. To find x-intercept, we need to setting y equal to 0 or setting fx equal to 0. So our function fx is 7x minus 1 over 5 minus x equal to 0. So from here, we will get 7x minus 1 equal to 0. Then we get x equal to 1 over 7. So we get the x-intercept 1 over 7, 0. Means graph will go through at the coordinate 1, 7, 0. Next, find y-intercept by setting x equal to 0. Means we find f0 equal to, substitute x equal to 0. So 7 multiplied by 0 minus 1 over 5 minus 0. So f0 equal to negative 1 over 5. So y-intercept is 0, negative 1 over 5. Means the graph through at point 0, negative 1 over 5. Next, we find vertical asymptote by setting qx or denominator equal to 0. As our function fx equal to 7x minus 1 over 5 minus x, so we set the denominator 5 minus x equal to 0. So we get x equal to 5. Then we need to test the vertical asymptote by evaluate the limit for the function fx when x approach to 5 from the right side. Also, limit for the function fx when x approach to 5 from the left side. Alright, first find limit fx, x approach to 5 from the right side is equal to limit x approach to 5. The sign is positive, means from the right side. For the function fx is 7x minus 1 over 5 minus x. If we substitute x equal to 5, then we get 35 minus 1 is 34 over 0 is equal to infinity. Then we need to test either the limit is positive infinity or negative infinity. As our limit x approach to 5 from the right side mean x is the number at the right 5. For example, x equal to 6. Then we can test into our function 7, substitute x equal to 6 minus 1 over 5 minus 6. So this one we get 41 over negative 1. So our answer here we have sign negative, so that we get the limit is negative infinity. Then evaluate limit fx, x approaches to 5 from the left side is equal to limit x approach to 5 from the right, so we put sign negative. For the function fx is 7x minus 1 over 5 minus x. Then substitute x equal to 5, so we get 35 minus 1, 34 over 0 is equal to infinity. Then we need to test either our limit is negative infinity or positive infinity. As our limit here, x approaches to 5 from the left, means the value of x is before 5. For example, x equal to 4. So we can substitute into our function 7 multiplied by 4 minus 1 over 5 minus 4. So equal to 27 over 1. So we get the value is positive, means our limit is positive infinity. It also can be concluded that vertical asymptotes is x equal to 5. Next, find horizontal asymptote. To find horizontal asymptote, we need to evaluate limit for the function fx when x approach to plus minus infinity equal to limit x approach to plus minus infinity for our function 7x minus 1 over 5 minus x. If we substitute x equal to infinity, then we will get infinity over infinity is the indeterminate form. So we can divide each term by the highest power of x. So for our function here, we have x, so we will divide each term by x. So we will divide 7x minus 1 divide by x over 5 minus x over x. Simplify this one, so we get 7 minus 1 over x over 5 over x minus 1. Then we can substitute x equal to infinity. So 7 minus 1 over infinity over 5 over infinity minus 1. 1 over infinity is equal to 0. 5 over infinity equal to 0. So we get the answer is negative 7. It also can be concluded that horizontal asymptote is y equal to negative 7. Next, find first and second derivative. To find first derivative, we need to use a quotient rule. vu prime minus uv prime over v square. U is equal to 7x minus 1. V is equal to 5 minus x. So u prime is equal to, differentiate 7x minus 1, we get 7. V prime, differentiate 5 minus x, we get negative 1. So substitute into f prime. Substitute v is equal to 5 minus x. Multiply by u prime is 7 minus u is 7x minus 1. Multiply by v prime, negative 1. Divide by v square. V is 5 minus x square. Then expand 5 minus x multiplied by 7. We get 35 minus 7x. And then minus multiplied by minus 1, positive. So we get positive 7x minus 1 over 5 minus x square. So negative 7x plus 7x, then 35 minus 1 is 34. So we get f prime x is 34 over 5 minus x square. Then find second derivative. We can rewrite f prime x equal to 34 multiplied by 5 minus x to the power of negative 2. So that f double prime becomes 34 multiplied by negative 2 multiplied by 5 minus x to the power of negative 2 minus 1 is negative 3, and then multiply by differentiate 5 minus x, we get negative 1. Then we get f double prime is 68 over 5 minus x to the power of 3. Next, find extremum and inflection point. To find extremum point, we need to setting f prime x equal to 0. So our f prime x is 34 over 5 minus x to the power of 2 equal to 0. Since we cannot evaluate the value of x, it can be concluded that no extremum point. To find inflection point, we need to setting f double prime is equal to 0. So our f double prime is 68 over 5 minus x to the power of 3 equal to 0. Since we cannot evaluate the value of x, it can be concluded that no inflection point. Alright, now we can sketch the graph. Please take note the important points: x-intercept 1 over 70, y-intercept 0, negative 1 over 5, vertical asymptote x equal to 5, and horizontal asymptote y equal to negative 7. To know the shape of our curve, we can find the increasing and decreasing function and also their concave up and concave down. We can test at vertical asymptote at x equal to 5, then test in the first derivative to know the increasing and decreasing of the function, and then test in the second derivative to know the concave up and concave down. So here is x less than 5 and here is x greater than 5. So we will test for x less than 5. For example, 0. Please check when we substitute x equal to 5 into the first derivative, we get positive numbers. It means the function will increase at x less than 5. And then if we substitute x greater than 5, for example, 6, substitute x equal to 6 into the first derivative, also we get the positive value. So that the function also increase when x greater than 5. And then test the value for x less than 5. For example, 4, substitute into the second derivative, we get positive value. Positive value means function will concave up at interval x less than 5. And then substitute for x greater than 5, for example 6, substitute 6 into the second derivative, then we get negative numbers. So function will concave down at the interval x greater than 5. Alright, for x less than 5, the combination of increasing and concave up, if we draw the concave up, we draw from here, we going down, and starting here, we will going up. So the curve will increase at this part. So we will just take the curve at the going up. So this curve for x less than 5, we just take the increasing curve. So it can be concluded curve for x less than 5 is this one. For x greater than 5, the combination of increasing and concave down. So if we draw the curve concave down, starting from here, going up. And from here is going down. So the curve combined with the increasing. So we take the curve when we write the increasing function. So the curve just like this. So for x greater than 5, the curve is like this. Alright, now we will sketch the graph. First, we put the vertical asymptote x equal to 5. X equal to 5 is vertical asymptote. Vertical asymptote must be a dot line like this. Then draw the horizontal asymptote y equal to 7. Also a dot line, horizontal asymptote at y equal to negative 7. Then plot the x-intercept 1 over 7, 0. Here 1 over 7, 0. And then y-intercept 0, negative 1 over 5. Here 0, negative 1 over 5 is y-intercept. Alright, now we can try to sketch the curve for x less than 5. Just now this curve for x less than 5 and must be cross the x and y intercept. So we can draw the curve cross at y and x intercept. Okay. And for x greater than 5, this curve, this is rational function, so the other curve must be opposite of the curve. So it must be here. Alright, finish sketching the graph of rational function. Thank you for watching.